In example 4, we have a 0 to the power 0 type. So we're going to have, in this case, when I substitute in 0 as x goes to 0 for the sine value, that's going to be sine 0 is 0. And then for the exponent, we're going to end up with 0 to the power 0 like this. Now, to be able to use L'Hopital's, we're going to have to put this into a ratio. To get this into a ratio, we need to apply a log to this. So we're going to let the y, we're going to just say y equals sine x to the power x. And then we're going to say that log y is equal to log sine x. And then we bring the power down. So we end up with the multipliers, which we can put into a ratio. So we can say that log y is equal to the limit as x approaches 0 from the positive side of, in this case, I'm going to rewrite this as a ratio, log of sine x. And this is going to be 1 over 0 from the positive side, 1 over x. And then now when we put it into L'Hopital's, when we evaluate this limit, the numerator, sine x, log sine x, when we plug in 0 into sine, we get sine of 0, 0. Log of 0 is negative infinity. So we're going to end up with negative infinity. And in the denominator, as we approach 0 from the positive side, in 1 over x, this is going to be equal to positive infinity. So we're going to end up with infinity over infinity. And this is a condition where we can use L'Hopital's. Okay, so I'm going to apply L'Hopital's here. So I end up with the limit as x approaches 0 from the positive side. The derivative of log of sine x is going to be 1 over sine x. And then applying chain rule, the derivative of sine is going to be cosine x. And in the denominator of this, we're going to have the derivative of 1 over x becomes negative 1 over x squared. Okay, so we're going to rearrange this then. This becomes the limit as x approaches 0 from the positive side. This is going to be cos x, so I'm going to move these terms around. So this is going to be x squared cosine x over sine x. Okay, and we're going to put the negative there. Okay, so when I evaluate this then, I'm going to still end up with, when I plug in x is 0, I'm going to get 0 in the numerator. I plug in x is 0, I get 0 in the denominator. And again, I end up with a 0 over 0. But that's okay because, again, that's a condition which I can apply L'Hopital's one more time. So applying L'Hopital's one more time, I'm going to end up with limit as x approaches 0 from the positive side. This is going to be negative 2x cosine x plus x squared times, I'm applying the product rule here in the numerator, so the derivative of cosine is going to be negative sine. In the denominator, the derivative of sine is going to be cos, so we end up with cos x in the denominator. Now at this point, when I evaluate this limit, I'm going to plug in 0, so I end up with negative 2 times 0 is 0, so I get 0 plus x squared is 0. In the denominator, we're going to end up with cosine 0 is 1, and so that's going to be equal to 0. So we now established that the log y is equal to 0. That was what our limit was. So since we have log y is equal to 0, then we can solve for the y, which is our original limit. So y is equal to e to the 0, and that gives us the limit equaling 1. So that represents then our limit of sine x to the power x. So that is equal to 1. Example 5 is an infinity minus infinity type. For these types, we need to make this into a common denominator so that we have a ratio. So I'm going to put this into a common denominator, so I get the limit as x approaches 0 from the positive side. This ends up being x minus square root x over the denominator x root x. Okay, so now we have a ratio. We can now try to evaluate this limit. And when we do, we end up with 0 over 0. So again, that is perfect for L'Hopital. So we're going to apply L'Hopital's here. So we have our condition for L'Hopital's. And when we apply L'Hopital's, we're going to end up with the limit as x approaches 0 from the positive side. The derivative of x is 1. The derivative of square root x is 1 over 2 root x. That's our numerator. In the denominator, we're going to use the power 3 over 2. So it becomes 3 over 2 x to the power 1/2, or square root x. Okay, so at this point, we can simplify this. So we get the limit as x approaches 0 from the positive side. And I'm going to multiply the top and bottom by 2 root x. So 2 root x over 2 root x to simplify this. So we end up with 2 root x minus 1. And in the denominator, the square roots become x. The 2's cancel out, so I end up with 3x. So plugging the 0 in here, I'm going to end up with 0 minus 1. And this is 3 times 0 from the positive side. Well, we end up with, I'm going to factor the negative out, 1 over 0 from the positive side. So this works out to be infinity, for positive infinity. So we end up with negative of positive infinity, or the limit is equal to negative infinity. So this limit, when evaluated, is equal to negative infinity.